Hello, this is Mr. Habtu. Let's try to express or to sketch a graph of a function using the applications of derivatives. So if you have a given function x to the power of 4 minus 6x squared, then find the x-intercepts, the y-intercept, the critical numbers, and develop the sign chart for the first derivative using the critical numbers so that you can determine the monotonicity intervals. The intervals at which f is strictly increasing or strictly decreasing. You can determine using the sign charts local extremes, local maximum and local minimum. And after developing the second derivative sign chart, you can determine the concavity interval, whether the graph is concave upward or concave downward. And we'll find the inflection point so that you can sketch the graph of the curve. So if the function is given by f of x, which is equals to x to the power of 4 minus 6x squared. So numbers which makes x to the power of 4 minus 6x squared is equals to 0 are x-intercepts, or the zeros or the roots of the given function. If we take x squared as common, then we're left with x squared minus 6, which is equals to 0. So x squared is 0, or x squared minus 6 is 0. So that x squared is 6, or x is plus or minus square root of 6. So the x-intercepts are 0, 0, square root of 6, 0, and minus square root of 6, 0. The graph crosses or touches the x-axis at 0, 0, square root of 6, 0, minus square root of 6, 0. The second thing is the first derivative at 0, which is equals to 0. To find the critical numbers. Critical numbers are numbers which makes the first derivative of the given function 0. So the first derivative x to the power of 4 minus 6x squared will be 4x cubic minus 12x, which is equals to 0. If we take 4x as common, then we're left with x squared minus 3, which is equals to 0. This can be expressed as 4x into x squared minus square root of square, which is equals to 0. Or x squared minus square root of 3 square can be factorized as x plus square root of 3, x minus square root of 3, which are 0. So numbers which makes the expression 4x times x plus root 3 times x minus root 3, which is equals to 0, are critical numbers. The critical numbers are 0, minus square root of 3, and square root of 3. So using the critical numbers, we can develop a sign chart. The critical numbers are minus square root of 3, 0, and square root of 3. And the factors of the first derivative are 4x, x plus square root of 3, x minus square root of 3. So f derivative at x is the product of the three factors. So 4x is 0 at x is equals to 0. And if you take any number which is less than 0, so we'll have a negative sign. If you take any number which is greater than 0, you will get positive sign. X plus square root of 3 is 0 at x is equals to negative square root of 3. If you take any number which is less than negative square root of 3, you will get negative sign. If you take any number which is greater than negative square root of 3, you will get positive sign. X minus square root of 3 will be 0 at square root of 3. So if you take any number which is less than square root of 3, you will get negative sign, and positive if you take any number which is greater than square root of 3. So the first derivative is the product of the three factors, negative times negative is negative, any number times 0 is 0, negative times negative is positive, anytime number times 0 is 0, positive times negative is negative, and 0 at square root of 3, then positive times positive is positive. As you look from the graph, the function is strictly increasing if the first derivative at x is greater than 0. So as you look from the sign chart, the first derivative is greater than 0 between minus square root of 3 and 0, as well as from positive 3 up to infinity. The graph is strictly increasing at this point, and it's strictly decreasing. A graph or a function is strictly decreasing if the first derivative is less than 0. So the first derivative is less than 0 over here, so that the function is strictly decreasing from negative infinity up to square root of negative square root of 3, and is negative over here from 0 up to the square root of 3. The graph is strictly decreasing over the given points. The other thing is local extremes, local maximum and local minimum. So if the first derivative changes sign from positive to negative, then you will have local maximum as a given point. So as you look from the sign chart, the graph changes sign from positive to negative at x is equals to 0. At x is equals to 0. It changes sign from positive to negative. So that local maximum is f of 0 at f of 0, 0, f of 0, which is 0, 0. If you substitute the 0 as a given expression, the other thing is local minimum. The local minimum is as a point which changes the first derivative from negative to positive. So as you look from the sign chart, the first derivative changes sign from negative to positive at square root of negative square root of 3 and at square root of 3. It changes sign. So that local minimum is at f of square root of 3 and f of square root of minus 3. Substitute if x to the power of 4 minus 6x squared is the origin function, so that the local minimums are square root of 3 and f of square root of 3, negative square root of 3 and f of negative square root of 3. This implies the local extremes are, or the local minimum are at square root of 3. If you substitute square root of 3 over here, square root of 3 the power of 4 is 1/8. Of course, square root of 3 square times square root of 3 a square, which is 3 times 3, 9. 9 minus 80, which is minus 9. Negative square root of 3 minus 9. These are the local maxima or minimum. Sorry, local minimum are at square root of 3 minus 9 and square root of negative square root of 3, 0. And at 0, 0 is the local maximum. The other thing is the concavity interval. We have to use the second derivative. Remember that the function is given by x to the power of 4 minus 6x squared, so that the first derivative will be 4x cubic minus 12x, and the second derivative will be 12x squared minus 12. So let's try to find the numbers which makes the second derivative 0. 12x squared minus 12 is 0, or 12x squared is 12, or x squared is 1, or x is plus or minus 1. So the inflection points inflection points will be 1 and f of 1, -1 and f of -1. If you substitute the numbers 1 and -1 as the original function x to the power of 4 minus 6x squared, then you will get -5, and of course if you substitute -1 you will get -5. These are the inflection points. Then the other thing is how to determine the concavity intervals. So the numbers -1 and 1 are numbers which makes the second derivative 0. The second derivative of f of x is given by x squared minus 12. 0, 0 at both -1 and +1. So if you substitute any number which is less than -1, you will get negative sign. If you substitute any number between -1 and 1, for example, if you take 0, you will get negative number. If you substitute any number which is greater than 1, you will get positive 1. Positive 1. Of course, if you substitute negative, you will get positive, since any number negative substitute at x squared positive, since the square of negative numbers is positive. So that the function is concave up, concave upward. As the point is, at which the second derivative is greater than 0. So that concave upward as the intervals from -infinity, -1 and 1 infinity. And the graph is concave downward if the second derivative at x is less than 0. So that is between -1 and 1. Finally, let's sketch the graph of the function. So remember that the x-intercepts are 0, 0, square root of 6, 0, minus square root of 6. So the graph crosses or touches the x-axis at minus square root of 6, at 0, and at square root of 6. The y-intercept is 0, 0, so that the graph crosses the y-axis at 0. The critical numbers are 0 itself, square root of 3, and negative square root of 3. The local maximum is at 0, 0. The local minimum is at square root of 3 and square root of 3 minus 9. And here we have square root of 3 minus 9 are local minimums. Local minimums. And the local maximum is at 0, 0. So as you look from the given expressions, the graph is strictly increasing from -3, negative square root of 3 up to 0, square root of 3 up to infinity, and strictly decreasing from -infinity up to negative vertical 3. The inflection points are -1 and -5. Here we have -1 and -5, 1 and -5. Inflection points are points at which the graph changes from concave upward into concave downward, or from concave downward up to concave upward. So as you look from the concavity interval, the graph is concave upward from -infinity up to -1. It is concave upward from -infinity up to -1. So that -1, -5, and 1, -5 are inflection points. That means the graph changes from concave upward into concave downward as the inflection points, from concave upward into concave downward. Then you will have another inflection point, which is minus 1 and -5 is the inflection point. -1, -5. So as you look from the graph is concave upward from 1 up to infinity. Here we have from 1 up to positive infinity. the graph is concave upward from 1 up to positive infinity. So it's concave upward up to positive 1, I mean minus 1, then concave downward between minus 1 and 1, concave downward, since the point is minus 1, minus 5, and 1, minus 5 are the inflection points. So the graph is concave upward, then at the inflection point it will change into concave downward, then you will have another inflection point, then it will be changed into concave upward. This is all about the given function f of x, which is equals to x to the power of 4 minus 6 x squared. Don't forget to like, share, and subscribe. Thank you.